So this video is just going to be basic usage on how to use my memory class and also my overlay class to do some really beginner level game hacking. It's going to cover unlimited ammo and editing the time scale to both slow down time and speed up time. You could, for the time scale, you could use that so that whenever you hold a hotkey down, it becomes really slow, then you get really good aiming, or whatever you want to do. But this is going to be a bit of a longer video because there's a lot to kind of go over, probably too much to go over, but I'll try to explain kind of the best I can. The code in this video will also be included on the GitHub page in the example folder, so that if you're not really interested in the video necessarily, you just want to see what the code looks like, you can just go head over there and check that out. Okay, to get started, the first thing you're going to need is my memory class. You technically could use a different method if you want, but my examples here are going to use some specific functions which only exist in this class. But you can find the link in the description, which points to my GitHub here, and you can download it either through the releases on the right, or you can left-click this code and then download zip here as well. They'll give you the same thing. In this case, I'll download from the releases, and then you would click source code and it would download. But I went ahead and opened the zip here, and you want to go to where your script is located and drag just these three files, the two DLLs and the AutoHotkey script, into your script directory. If you want to have a cleaner environment, you can make a new folder. I'll call this one res for resources, and I'll just move these into there. And when we go to the scripts, you can just do include res and then the memory class. And the DLLs, you do have to include this folder again there. So when we do when we make a new instance of the class, we specify the program identifier. It can be title name, executable name, class name, whatever you want to use. The second parameter is access, which we kind of just want to leave alone because full access is pretty much what I want here. But the third parameter is where the DLLs are located. If you leave this blank, it'll just assume they're in the working directory of your script, the same directory. But since we moved it into a folder, we're just going to type in res. So it'll tell it to look in the res folder in the working directory. That way they can be out of the way, but still be used. Anyway, that's pretty much how we start with the AutoHotkey scripts. The next part is the more interesting part, which is finding the addresses through Cheat Engine. So we're going to activate the game. And for this video, I'm going to be using Prey, which is a semi-modern game from 2017. The reason I chose this one is because it has a lot of the interesting things that you'd want to do with hooking functions and changing things. Now, just keep in mind, this is a single-player game. You can use this on multiplayer games. I don't condone it. I don't really care for cheating there, but I'm also not going to tell you what to do. It's your own prerogative. Do what you want to do. But just know that if you do plan to do that, a lot of games have anti-cheats, and my library has no measures against that. So, do that at your own risk. For the purpose of this videos, this is single-player games. There's no chance of getting banned or anything else. This is just for having fun in a single-player game. So I'll go ahead and move on now. So in this game, I've never made cheats for it before, so I'm not sure exactly what I'm going to be doing yet. I do have an idea, though, especially with this gun here. This is the beginning of the game, about 30 minutes in. I just got past this tutorial section just because it was, it's very boring. It takes like 30 minutes. But I got my first gun here, and this is the first thing that I want to make a cheat for, which is unlimited ammo. So if you look at the gun in the bottom right, you'll see two numbers, a 42 and a 53. So I'll shoot the gun, and only the top number changes. So likely that number refers to the clip size, and the bottom number probably is the reserve ammo or the total ammo. Could be one of the two. And the bottom number goes down, top number goes up. Okay. So I'm going to do a scan, and I'm going to look for both values simultaneously. I'm going to look for possibly the lower value and the total value. So 42 plus 48 is 90. So I'll do a scan for 42 to 90. I'm going to do a 4-byte scan. Sometimes this data can be stored as something else. Generally with things like this, they're usually integers. They could be 4 byte, 2 byte, 1 byte maybe, but almost never floats or doubles. In this case, I'm just going to assume it's 4 bytes. It probably is. So I'm going to do a value between 42 and 90. And I'll go back to the game, and I will shoot the gun. I should mention as well, I'm going to be using hotkeys for this video. If you want to set up hotkeys, you can go to Settings, and then Hotkeys, and then I'm using these 4 mainly, which is next scan, increase, decrease, changed, unchanged. So here I'm going to do a decreased value, because it went down by 1. Shoot again, decreased, 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 and then I'm going to do 1 unchanged. And we have exactly 2 addresses. They do line up exactly with what you would expect to find. The 37 is the top value, which is probably our clip, and then the 85 is the total ammo for the gun, clip plus reserved added together. Now for me, I'm more interested in the top number, which is the clip, because you can have unlimited reserve ammo, that's fine, but you'll still have to reload. But with unlimited in the clip, you never have to reload. So I'm going to right-click, well, I'm going to add this address first, then I'm going to right-click, find out what writes to this address. This is specifically the function that is responsible for setting this value. And I'll shoot my gun, and I'm getting some hits on some functions, and reloading doesn't change anything. Oh, it does actually, but it's still the same address, so that's perfect. That tells me that this address is probably an address that is just setting the value, and maybe it does some other checks for maybe if you have too much ammo or too little ammo. So it probably takes a parameter that literally just sets the new value. So this function right here is what is responsible. Now this is called ASM. You can kind of think of this as like a really low-level programming language. Well, I mean, it is a low-level programming language, but there are registers. In this case, EDX is the register that holds the new value, and we are writing into the address at RCX plus 484, so you can think of this as a pointer to another address. The brackets mean we're writing into that value at that address. So we are writing the new ammo count into that address. That address being this one right here. So if we just right-click on it and do replace with code that does nothing, that means when it gets to this point in the function, instead of setting the new value, it will just do nothing. So the old value will just be there forever. So if I shoot the gun, it does not go down at all. Our reserve ammo does go down though, so maybe we don't want that to happen, and we can do exactly the same thing. Right click on it, find out what writes to this address, and shoot the gun a few times. Reload as well. Oh, I guess we can't, because we're not running out of ammo. It doesn't really matter though. So show and disassembler, and it's a similar thing. It's moving the value of EDI into the value of RBX plus 54. So we're going to replace the code that does nothing, and now we have unlimited ammo in the reserves and the clip. So that's pretty good. So because we didn't have to really rewrite functions, NOPs are the easiest thing you can do. It's extremely, extremely easy. It's really easy to program an AutoHotkey. So I'm going to write the code really quick, and then I will come back and explain it. Alright, so we're all set, and I'll go ahead and explain the function here. It's pretty simple. Firstly, I'm running it as administrator. It's not required in all games. I don't think it's required in this one, but it's just like a general rule. I usually run as administrator. This is a custom function, but you can just right-click the script and do it that way as well. I'm including both the memory class and the overlay class, but these left-right symbols, the arrows, they mean I'm including them from my own library as opposed to like a file in the directory. But you can just do like this instead. Just for me, the one that I'm working on in my library is more up to date, so I need to use that one for the time being. I'm specifying the overlay, the memory, and if you noticed, which you may have here, is that this function is stored in pray.dll instead of pray.exe, which is usually how functions work. They're usually stored in the main executable, not a separate DLL. So because of that, I have to get the base address of this DLL instead. but that's no big deal. The library, the class does have a function for it. I'm going to set a variable for the infinite ammo state, so we can toggle it on and off, that we can play with it. And then the main loop for drawing, which for now is just a simple text that says if it's on or if it's off. And then we get to the hotkey, which does the actual thing. This is responsible for turning it on and off. So if we turn it on, it takes the two addresses, which we found up here. If you click on it, click Show Disassembler, this is the address that's responsible. In this case, it's 6 bytes, which you can look at the operation. On the left side, these bytes here, there are 6 pairs of 2, 8991, 844000, etc. So we want to nop that. We want to nop 6 bytes. So right here, we nop at that address 6 times, and then we do 3 for the other one. And then when we want to restore original functionality, we rewrite the original code back. So in this address, the original code is right here, and the other one is right here. And that's it. So if we run this, and we go into the game, so I'll go ahead and run this, and I'll go in the game. It says Alt plus F1, infinite ammo is off. And I'm going to move this window up here so you can see in real time what happens. So when I press Alt F1, you'll notice all of this gets knocked. And then if I press Alt F1 again, it gets restored. So if I have this off and I shoot, no ammo gets used. So there you go. I mean, that's infinite ammo, as easy as it gets, a simple nop. It might get more complicated later, but we'll keep moving. Let's see what else we can find. So something I noticed earlier is when you open the weapon wheel, if you look really quickly, I don't know if you noticed that, but there's a small slowdown and speed up when you do that. That tells me that this game has an easy way to access the time scale, which means we could turn on slow-mo or super speed whenever we wanted to. Now, Cheat Engine has something known as a speed hack, which you could use, but I don't generally like to do it that way. I like to find the variable that is responsible for the time scale in-game and use it that way, because it's actually supported by the game and it works a lot better. So, with time scale, you can always assume that it's going to be a float or a double. I'm going to assume that it's a float in this case. And the value when you're at full time scale is always going to be a 1. And when you are paused, it's going to be a 0. So when I say paused, I don't mean like literally at the pause screen, because this right here, you might think that this sets the time scale to 0, but it often doesn't. This is a different thing, which I will demonstrate here. So in game, you have time scale, which is usually 1.0. When you are running your main function here in the game, you are going to do game code, so like do game code, and maybe get a time scale. This is extremely simplified, but you do something like this. And when you pause the game, it's going to do something like if not game paused. So it's going to say if the game is not paused, then do the game code. This does not affect the time scale usually, so I'm going to assume that in this case it is the same. So right now, even though we are paused, the time scale is most likely going to be 1. So I'm going to search for a float of the value of 1. And now I'm going to access my wheel, which does set the time scale to 0. So now I'm going to come over here and do 0. And then I'm going to come back in game. And now I'm just going to do some basic increases, decreases for speed. So decreased, increased, decreased, increased, decreased. Oops. We're going to do increased, and then I'm going to do a couple unchanged. Okay, so we have quite a few addresses here. One thing to note is that these addresses that have decimal points afterwards are not going to be it. There may be a way to filter these out, I'm not sure. But I'm going to delete some of these addresses here, because these will never be it. Timescales usually cap out at exactly 1 or 0. they don't have a bit of data after that. So I'm just going to delete those, and it gives us a little bit less to work with, which is good. And now I'm just going to, okay, well this one is clearly not it. I'll remove that really quick. Now I'm just going to look what happens when I do this. So that's interesting to me. It looks like most of these addresses right here are probably not it, but these three right here and some of these down here, these did change linearly, which is what's happening in game. It's slow. It goes from 1 to 0 and 0 to 1 instead of instantly. So what I'm going to do is I'm going to take these three addresses and I'm just going to start from here, and I'm going to set these, change the value to 0.5. Now, when you change things like this in batches and you don't know what they are, this could crash your game, so be ready for that. That is just how it works. There's probably better ways to find these, but for me, this is like the simplest, easiest way. So we're in game, and I am actually moving slower, so one of these addresses is the real time scale, so I'm going to one by one change them. So I'm still slow, so it wasn't that address. I'm going to change this one. And I think I'm moving normal speed now. I am. So this is the timescale address. So there's two things you could do here. One is that you could right click this and you could do a pointer scan for this address. Now this is a cool feature with Cheat Engine where after maybe 5 or so scans to filter out bad addresses, you can usually get a stable pointer that will always point back to this address, so then you can read through my class to get the address pointed out by that pointer. But since we're playing a single player game and we don't care about writing our own custom functions in memory, that's what we're going to do here. Okay, so now I want to find out what functions access this address so that I can hook them. So I'm going to right click on it and choose find out what accesses this address. And I'll just move around the game a little bit. And it looks like we have two addresses. One is even updating when it's paused, which is interesting. And looking at them, I see that one of them, this one right here, is loading the address from RCX, RDX, and 18. And this one's loading it from a static offset, which is more interesting to me. So I'll probably use this address here. So I'll click Tools, Auto Assemble, Template, Cheat Table Framework, and then Template again, Code Injection. And then from here, I'll create a new label called Speed, and I'll register it as a symbol. And symbols in Cheat Engine mean you can specify the variable name Speed when you're talking about an address, and it will automatically resolve to the address that's in memory. So underneath Exit, I will type in Speed, and now this label corresponds to a memory address. Do not type Speed underneath this line where it says the entry point, because if you do that, it will actually write it here, and it will mess up the whole program and it will crash. Don't do that. Now that we have this, again, we're not changing this function. We're going to keep it the way it is. All we want to know is where does the timescale exists so that we can write to it. So I'm going to move this address into the speed variable. So I'm going to do move into the value of speed, RDI -1AE. I don't know if you can do it that way actually, but I'll see if, like, the great thing about Cheat Engine, it will tell you if it doesn't work. So I'll click File, Assign to the current cheat table, and that doesn't work. So what I'm going to do is I'm going to look at the original code and see if there is a register that is not being used here. And it looks like Rax is not being used. It's because it's being immediately written into afterwards, and nothing's accessing it. So essentially, it's a free register. So I'm gonna move, or I'm gonna load effective address into Rax. The value, well, not the value, but RDI -1AE. This will move that address into Rax, and then I will move that into speed. And because rax is going to get overwritten by the original function anyway, I don't need to manage the stack by pushing or popping it. I can just leave it like this. But let's assume that it was going to be accessed afterwards. What you can do is you can push it, and then you can pop it afterwards. This pushes the value that's on it right now onto the stack. You change it, and then you pop it and restore the old value onto the stack. So I'll just leave it as this anyway, just because a lot of times you will have to do it like this. Okay, then we'll do file, assign to the current cheat table, and if I turn that on, you'll notice right away this is doing a jump, and if we follow it, here's our push, our load effective address, move, pop, original code, and then we're jumping back. Now this right here, this push afterwards, is actually just a pointer. In fact, you can see in Cheat Engine its speed. This is the value pointed at by speed. So we will go back, and we can type in speed into here, and we know it's a pointer. And it's specifically a pointer to a float value, which is our timescale. So now we have a hook into a function that automatically finds the timescale address for us, so that we don't have to worry about pointer scans. And if the program ever got updated in the future, you could do an AOB scan to find this function again and just hook it again. And it's very easy to do it this way. Okay, so now that we have the basics of that done, we can convert this into AutoHotkey code. So I'm again going to write that really quick, and then I'll go over how to do it. So I'll be right back. Alright, that should do it. So a couple things here. We are creating a new instance of the hook helper class, which is in my memory class at the bottom. This is a simple class for making hooking and ASM stuff easier. And it takes a few parameters. The first one is a reference, or reference to the memory class, which we created above. This is so that it has access to all those functions. The second parameter is a static address to store the pointer of this region that we're going to commit to. So the way that I usually find that is I add an address manually, and I just type in the executable name, in this case pray.exe, and this will take me to the executable base address. And then I press Ctrl D, and I just scroll down, and I look for a bunch of CCs. So in this case, let's see where there are some at. Here's some right here. So I look for a bunch of these. Now, what these mean is that if ever a script, not a script, but if ever a program hits these, then something has went wrong and it triggers a debugger event. They shouldn't ever get to any of these. So they're usually, they're put in between functions, and it helps to align the bytes as well. So essentially these addresses are never used for anything. So I pick one to just store my address. It doesn't matter where they are, just as long as they're static. And by finding them in the executable base address, they're going to be static. So if you are on 32-bit, then you only need 4 of these. If you're on 64-bit, you need 8 of these. So just, in my case, it's 64-bit. So I found an address that had 8, and I wrote the address down here, 1E04. And when this region gets committed, it will store a pointer at this address. That way, if I close this AutoHotkey program and I open it back up later, it will, when you call this hook helper function, it will determine if a pointer already exists here, and if it does, it will return that pointer instead of creating another region. But if it does not exist, it will create a region closest to this address. We want it to be close, that way we can do relative jumps to it. And if we look here at the helper function, so we have the size of the third one. I left that blank, which means it'll default to 1000, which is, I think, the minimum size that you can do. Start is how close it is. The init is the initial value when you're reading that static address. So it'll read a 4-byte value. If it equals CC, which means basically no pointer has written, then that's when it will commit the memory. Otherwise, it will read it as a pointer and return that. So the next thing we do is we reserve some memory in our region. Actually, this should actually be reserved as 8 bytes instead of 4. And what this does is it says when you call the hook helper function, it will reserve that memory. Half of that memory is reserved for executable code. The other half is reserved for like general purpose storage, writing values to and stuff. So this just says reserve 8 bytes in the storage area, and speed pointer is just going to point to those bytes. So nothing else will ever get written there. It will only ever contain the speed pointer. And this is an address to it. And then here are the strings. So if we go to here and we jump, this is what Cheat Engine has generated for us. And I have a helper function right here called convert CE string, and I'll show you how to use it really quick. If you have Cheat Engine string in your clipboard, you can run this function and it will convert it to this string here. So I'll go ahead and demonstrate how that works. So I'll copy all of this, and I'm not copying this bottom part because that's actually not part of the ASM. That's actually just some data storage. Press Ctrl-C, leave all of these checked, click copy, and it will automatically convert the clipboard to... Oh, actually, I gotta run the function first. So let's run that. We'll get an OK, and now it has converted it. You do have to do a little bit of touch-up here. For instance, this move into speed, we want to change this. So that's these bytes right here. You can also look at Cheat Engine here, and you'll see this big, long address. That's the address you want to change. And specifically, I'm going to be replacing this with a 64-bit little endian variable. So I'm going to do replace little endian 64. So REPL 64. And this will tell the write ASM function to convert this into the speed pointer, but convert it into little endian. Let me go a little bit down to cover this function so it'll make a little bit more sense maybe. So in this string are two unique words, REPL 64 and jump. These are going to get replaced with the arguments supplied in write ASM. If you don't have any of these, then it would just be that. But because we have two of them, we need to supply two values. The first one is going to be a pointer to our speed pointer, and the jump one is going to be where we are jumping back to, which will be when we jump back, it'll be right here at this address at 3FC. And essentially, that will convert that code into the correct relative jump address, and then the correct little endian address for these values automatically, so that you don't have to figure that out on your own. And with that, that's it. Now, because Cheat Engine is still hooking it, we need to uncheck that, and then it'll go back to the original value. And now we're going to run our scripts, and if you did something wrong here, the game will likely crash. So if it doesn't crash, then you did something right. Alright, so let's go ahead and press F9 to run it and see what happens. Okay, so the game did crash, so I did something wrong. I'll go ahead and boot it back up and we'll figure out the mistake. Okay, so I'm back in the game, and I'm going to go ahead and show you how to debug if something went wrong. So I'm going to leave this the way it is, and I'm going to go to Cheat Engine, and I'm going to set a breakpoint by going to Debug, Toggle Breakpoint, right before the function is called. Now, it'll automatically breakpoint in this instance because it's getting called constantly. But now I'm going to press F9, and it did hook the address, and we'll just keep looking to make sure everything looks good here. And it looks fine so far, so we'll follow that. And it looks like our ASM did not get written, so that seems like that's probably why. Okay, so that was my fault. I'm updating functions in real time as I do this, so I made a mistake in the hook helper class, and I dereferenced one of the variables, so it was actually pointing to null. I fixed that now, so if I press F9, you should see it in real time as it writes the function now. So there we go. So it wasn't writing the function last time, but it is now. And it looks good here, so I'm going to follow that, and it looks good. So I'm gonna remove the breakpoint and just run the script, or run the program rather. And the game didn't crash, so it seems like the code that we had was working all along. It was actually just an error in my class that I made earlier and forgot to fix, or didn't know about. But anyway, what we can do now is we can add a new text here, and I'll put this at 40. And this is Alt F2, and we'll do set timescale, and then we're going to write what timescale is currently, because now we have the address. So we can do m.read float for speed pointer, and speed pointer is holding a pointer, so we do actually need to read it with an offset of 0, because we need to read the address that it's pointing at, not just the address. And we'll see what that looks like. So I'll press F9, I'll come in game, and that does not look right. Might need another 0 here. Okay, that is right. I don't think that's right though. Okay, let me fix that. That's actually not how that's supposed to be. I'll be right back 1 second. Okay, I fixed that bug. It should just look like this instead. Because we would be reading the pointer from this address. We read the value of this address, and then we read the value of the next address with the 0 offset. So that should be correct now. So I'll press F9, and we do get a 1. So what we can do now is if we press Alt F2, it'll give us an input box for new speed. Let's try setting it to 0.3. And it looks like it doesn't do anything, so let's go see why that would be. Right float, speed pointer, new speed. Oh, yeah. Oh, true. This one also needs the offset of 0. If we reload that now, it should work. And we'll do Alt F2, and we'll do 0.2 as the new speed. And there we go. That's the new time scale. We can set it to, say, 3, and that's like really fast. Oops. And then when we enter this menu, this actually resets timescale. That way, like when we modify timescale, it doesn't mess up other functions in the game that would normally write it. That way, it doesn't interfere with it. But as you can see right now, the game did crash, so our other stuff isn't working either, or at least it's not turned on. But if we turn it on now by pressing Alt F1, we should notice that we have unlimited ammo. Even though the game crashed and things changed, because we're working with base addresses and offsets, and we're reiterating functions, it doesn't matter. It should work every single time. And then we can do Alt F2 to set the timescale to maybe like 5. And now the game is very, very fast, and we can go crazy, and we can just shoot super fast, tons of stuff, and it's very cool. Alright, well, that's it for now. These videos take quite a long time to make, so I think I'll end it there. You should get the gist of kind of how it works. You can... this is like the very surface of it. This is very beginner level stuff. When you get more advanced with it, you can change pretty much everything. I could potentially make more videos in the future covering more aspects. We'll just see if there's a demand for it. I'm not sure how many people even would find this useful, but I'm sure there's 1 or 2 people out there that might find it interesting. So hopefully you have fun with it. Let me know if you run into any issues or you have any suggestions or anything like that. You can message on the GitHub or my public Discord, which will be in the description. And yeah, I'll catch you later.